First you separate and then you integrate. Just follow these steps and you will do great. First you separate and then you integrate. Just follow these steps and you will do great.
Here's the season to be serving.
When I was solving equations, I was feeling amazing. All right, today, as you can see, we're talking about angle between vectors. And so I have two vectors illustrated here, and we're talking about the angle theta between those vectors right there. So let's say I call this blue vector the vector u. And then this blue vector is the vector u, and I want to kind of look at this as a triangle. So the length of this vector, of course, is the norm or the magnitude of u. And if I call the red vector v, then of course the length of that vector is the norm or magnitude of v. So I have two sides of a triangle of what I'm trying to pull off. And so I need the third side. And if you understand some of the basic elementary thing about matrices, if you understand some of the basic things about vectors, then you understand that the new green vector that I just put there is the vector u minus v. So its length, of course, is the magnitude of u minus v. All right, so I want to find theta. And so as you look at this triangle and you see an angle on the sides, it should kind of remind you of the law of cosines. So here's the law of cosines, where I have capital A, B, and C representing the angles and lowercase a, b, and c representing the sides. And of course, the side opposite the angle shares the same letter. And in this case, we have a squared is b squared plus c squared minus 2bc times the cosine of a. So notice when it's an a squared, when I'm solving for a, the side a, I'm going to take the cosine of the angle opposite of it. And then the other two sides, which in this case are b and c, are being squared and being multiplied by -2 in the equation. So if we equate that situation to what we have here with these vectors, and then using the law of cosines, then we get the following formula where we have the magnitude of u minus v squared equals the magnitude of u squared plus the magnitude of v squared minus 2 times magnitude u, magnitude v, cosine theta. So that's the law of cosine. So we're going to go ahead and work that out and see what happens. Before we get to that, we want to define just a few things. So we want to define the components of the vector u as u1 comma u2, the components of the vector v as v1 comma v2, and the dot product u dot v. It's the dot product right here. That's u1 times v1 plus u2 times v2. And then the magnitude or the norm of u squared, remember the magnitude of u is the square root of the square of the components, of the sum of the square of the components. And so if I square it, then there's no more square root. So the magnitude of u squared are just the components of u being squared added together. The magnitude of v squared are just the components of v being squared added together. And the magnitude of u minus v squared are the difference of the components of those two vectors being subtracted and squared and added. And this, the magnitude of, or the norm of u minus v squared, that's something that we're going to work out on paper. So let's go ahead and work this out and see what we can get from this formula. All right, so here's the situation at hand. Let's go ahead and work this junk out. The real work involved is going to be squaring this. Remember this is, u1 minus v1 squared plus u2 minus v2 squared. So that's going to be the bulk of the work. These two are simple. And these two, the norm of these two vectors or the magnitude of these two vectors, we're just going to leave it the way it is. There's nothing to work out. So the bulk of our work is going to be here, and it's going to be pretty good, but we're going to go ahead and tackle it anyway. So remember, the norm of u minus v is u1 minus v1 squared plus u2 minus v2 squared. So I'm going to go ahead and write what that is worked out. So u1 minus v1 squared would be u1 squared minus 2 u1 v1 plus v1 squared. So that's what we get for u1 minus v1 squared. And now I'm also going to do u2 minus v2 squared, which would be u2 squared minus 2 u2 v2 plus v2 squared. All right, so that's what we get there. Now, believe it or not, this very long expression is simply the result of doing the norm of u minus v squared. So all of this is simply doing the norm or the magnitude of u minus v squared. Remember, these two are pretty simple. You know, the magnitude of u squared is just u1 squared plus u2 squared, and the magnitude of v squared is just v1 squared plus v2 squared. And again, we're going to leave these as just norm of u, norm of v here. So let me go ahead and write what these are. I don't have a great deal of space, so I'm going to write it below. So now I'm going to do the magnitude of u squared, which was given on the definition sheet. And so that's just u1 squared plus u2 squared. And then the magnitude of v squared would be v1 squared plus v2 squared. And then the rest of this we'll just write the way it is, minus 2 norm u norm v cosine theta. All right, so there we go there. And for those of you who have watched my videos, you know there's a tendency on my account to, as I'm writing math expressions and equations, to kind of get it lean. And that notorious lean is happening here, but this is better than I normally do. So I'm fairly proud of myself. And there's a thing with dealing with vectors. You know, the normal convention when dealing with two vectors is the column vector u and v. You don't have to, but you know that's what we conventionally do. And you know, sometimes your u's and your v's cannot look distinct. So I try to put an emphasis on making mine look distinct. I know sometimes they may bear some resemblance, so I apologize if that's occurring. Now, so we have an equation here, a very long equation, but you know, as happens in many cases, we'll make it more simple. And we have identical items on both sides of the equal sign. And this is the left side of the equal sign. This is the right side of the equal sign. And as you know from algebra, when you have identical items on the same side, on opposite sides of the equal signs, they cancel each other out. So this u1 squared, they're going to cancel. u2 squared is going to cancel. v1 squared is going to cancel. And v2 squared is going to cancel. So all we have left on the left is simply negative 2u1 v1 and negative 2u2 v2. And all we have left on the right is negative 2 norm u norm v cosine theta. So let's write what we have left. So negative 2 u1 v1 minus 2 u2 v2. And that guy is going to equal negative 2 norm u norm v cosine theta. So that's what we have left thus far. And if you notice, every term has a negative 2 in front of it. So we're going to divide everything by negative 2. And that'll give us u1 v1 plus u2 v2. And that's going to equal magnitude u, magnitude v, cosine theta. And, you know, just I should have made this note earlier. This notation here for the magnitude or the norm of u and v, which of course means the length of u and v. Sometimes this notation is used with 1 bar instead of 2 bars. So it means the exact same thing. Just some people use 2 bars, some people use 1 bar. So if you were taught with a notation with just 1 bar on each side versus 2, this is the same thing. And when I use this word norm, you know, basically, if you've been taught with 1 bar, you've probably heard the word magnitude or length and probably haven't heard the word norm, but it means the same thing. So when you hear me say the norm of u, it means the exact same thing as magnitude or length of u. And again, the 1 bar notation is the same as the 2 bar notation. All right, so let's continue the process. So if you look over here in our definitions we gave, one was u dot v. And so if you look at this, this is actually u dot v. So I'm going to write this as u dot v here. So this is u dot v, and that's going to equal norm u, norm v, cosine theta. All right. And again, I'm not sure how far you guys have got into vectors, those that are watching. because in normal we're dealing with scalars, for instance. So I'm really addressing this dot product issue. When you deal with scalars like 2.3 is equal to 2 cross 3, those are like the same thing. For vectors, however, a dot product and a cross product are two different things. A dot product gives you a scalar, a cross product actually gives you another vector. So I say that, so when doing this, don't think that this dot I put here can just be interchanged with a cross. So when it comes to vectors, the dot product and the cross product are two totally different things. All right, but now remember, what we're trying to do here is we're trying to solve for theta. We're trying to find the angle between the two vectors, which is theta. So to get theta by itself, we're first going to divide by norm u, norm v. And let's do that on a separate sheet. So I'm going to divide by norm u, norm v, and I'll put the cosine theta on the left-hand side of the equal sign because that's what I want to solve for. Well, theta is what I want to solve for. So cosine theta would be u dot v divided by norm u, norm v. And if that's cosine theta, then theta, of course, will be the arc cosine of this stuff. So theta is the arc cosine of u dot v over norm u, norm v. So this is our formula. So this is what we're going to use to find the angle between vectors. So this is for the angle between vectors u and v. So basically, in order to find the angle between vectors, there are three quantities that you need to find: the dot product, the magnitude of u, and the magnitude of v. That's it, just three simple numbers. And you're just going to take the arc cosine of the quotient of those guys. So let's do one quick example. And so I'll just, create two random vectors real quick. And I'm doing vectors in the plane, two-dimensional vectors, but this can also work for vectors in space. But I'm just going to do vectors in the plane, two-dimensional vectors. And so let's say vector u. So I just want to make sure these vectors aren't orthogonal. Other than that, any numbers can work. So let's say vector u has components 3, -5. And let's say vector v has components -1, 10. And I'm going to find the angle between these two vectors. So I'm going to say find theta. But you and me understand theta means the angle between the two vectors. So I need to find my numbers first, my three numbers. So first number I'm going to find is the dot product, u dot v, and that's going to be 3 times -1 plus -5 times 10. It's going to be -3 plus -50, -53. But I'll write it so 3 times -1 plus -5 times 10. It's -3 plus -50, -53. And the norm of u is the square root of the components of u squared added together. So that's the square root of 3 squared plus -5 squared. So that's the square root of 34. And the norm of v would be the square root of -1 squared plus 10 squared. So that's the square root of 101. So I have my three numbers. Again, when finding the angle between two vectors, you just need to find the dot product of the two vectors and the magnitude of both vectors, and then you're able to find the angle. So let's go ahead and find the angle theta. So theta is going to be some angle between 0 and 180 degrees, or 0 and pi radian. I'm going to find the answer in degrees. So this, of course, this is a calculation. I mean, I'm going to be taking the arc cosine of negative 53 over the square root of 34 times the square root of 101. So that's definitely something I'm going to do in a calculator. But let me write out what I'm going to do, and then I'll do the calculations in the calculator. So theta is going to be the arc cosine of negative 53 over the square root of 34 times the square root of 101. All right, so that's the calculation I need to make to find the angle between these two vectors. So let's go ahead and find this angle. I can't wait to see what this angle is. So here's my little calculator. There I was doing some other problem. Let me clear that. So since I was doing that, I'm pretty sure I'm in degrees. I am. So let's go ahead and do the arc cosine. And let's open up a fraction bar. And our numerator is negative 53. And our denominator is the square root of 34 times the square root of 101. And I just want to make sure I got everything typed in there good. One thing, just using the calculator when doing this, make sure that the second square root is not inside the first square root. There's no need to put a multiplication symbol between these two square roots, but you can if you want. And maybe that may alleviate some of the problem that I sometimes see of square roots inside of other square roots. So let's see what our angle is. Can't wait. So 154.7 degrees. So the angle between these two vectors is 154.7 degrees. So we will stop there. That's the angle between two vectors. We will see you next time.
Specialized in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section. Vocal toe to toe, impeccable, splitting your back, son. Simple as addition and subtraction, black thought, the infinite relax one.